Welcome to International Time Machine's video about servicing the rewind mechanism of the ITR master clock collection in production and in use from the early 1900s. This video will look at removing the movement and the weights, as well as servicing the cables, the switch, and the motor itself. The movement isn't all that different than many of the other clocks available in its era, but it's really the exceptional strength and durability of the rewind mechanism that's made this the workhorse of the industrial age. They're so well made that just about all of them can be brought back to life again. Here's a couple tips. The rewind motor uses 120 volt, a standard plug that usually attaches to a fuse block on the top of the clock. Make sure you've unplugged or disconnected the power before you touch anything inside, as there's a lot of hot contacts. A key component of the rewind mechanism is the switch that turns the motor on and off at the appropriate times. First thing we'll do is remove the cover for that and familiarize the fact that the roller inside moves from right to left. When it's on the right, the motor is on, and when the roller is moved over to the left, the motor is turned off. In normal operation, the roller is to the left and the motor is off, and once every 30 hours or so, the switch is turned back on again and the motor lifts the weights up for about a 1 minute duration. Before you remove the movement, the first thing you have to do is lock the cable drum so the weights don't fall when you pull the movement out. You loosen the adjusting screw, pivot the mechanism to find a slot on the cable drum, slide the mechanism over, locking it in, and retighten the adjusting screw, and that therefore locks the weights in place. To remove the movement from the back plate, there are 4 screws that hold the movement to the back plate, and they're tucked in the rear plate of the movement itself. And if you just take each one of those off and set them aside, usually the movement stays in place, and you can pull it off of the pins that hold it on as well. Moving the weights is usually a bit of a balancing act because they weigh about 11 pounds each. Make sure your drum is locked and then get a 1/2 inch wrench. And I usually put a clip on the top of the cable right next to the pulley, so that gives me a little bit of weight, but also keeps the cable from pulling back through and unwinding on the drum. Next thing is to loosen with a couple of turns the 1/2 inch nut on the top of the weight, and then you can usually turn them off by hand pretty easily, but again, keep in mind 11 pounds will want to fall. Follow the same process for the left weight, starting with a clip that will allow us to have some weight and some tension on the cable, and then using care, remove the weight itself from the cable. These cables can be adjusted and cut right underneath the nut, so that if you're replacing it, it's a relatively simple process. With the weights removed, it's now possible to test the operation of the mechanism using just your hands. You're now able to reach in and grab hold of the gears and support the weight of the clips instead of the actual heavy weights at this point in time, and move it back and forth, move it up and down with just your hands controlling the cable drum. This gives you a good sense of if there's any issues with the movement of the cable drum, or if the cables in fact need to be checked and see if they need to be replaced. But it also gives us a chance to take a close look at the switch and how that operates. As we simulate the weights falling and moving down, we can keep an eye on the switch roller, which flips over after what would be about 30 hours of movement, and it immediately turns the motor back on to pull the weights back up until it gets to the top, and it turns off. So this is a way by hand you can actually test the operations. If you determine that the cables need to be replaced, you'll have to remove the cable drum, which is held on by those 3 screws. But before you do that, you have to take off the worm drive in the upper left side of the drum by removing its 3 screws and then lifting the worm drive assembly itself off of the back plate. Having that off, you should now be able to remove the screws and then the drum itself, but you want to make sure you always keep the drum firmly on its axle. If it falls off, there are some ball bearings inside the drum which could fall out, and you could spend hours trying to find them. But otherwise, you can analyze the drum, take a look at the cables, see if they need to be replaced, and also see where they're mounted. The left cable comes in through the center, and the right comes in towards the back side of the drum, and they have accompanying securing screws on the back side of the plate. When you have them properly adjusted, the top of the weight should be level with the back plate mounting screws, the lower level of those. In order to successfully reinstall the drum back on the back plate, you once again have to come back to the activation of the switch on the back plate itself. Familiarize yourself with when does the turning of the drum actually move the roller over from left to right. If you take a look underneath the cable drum, you'll see that on the back there is a little nub that sticks out the center of the axle. That engages with a seashell shaped gear that is mounted on the back plate, and each time the drum goes around a rotation, it moves 1 notch further on the seashell until after 30 hours it activates the switch. You can get a closer look at the nub there. Again, when you're aligning the weights at the top of the screws, that seashell position does come into play, and therefore you got to work with it a little bit. You rarely need to remove the motor, but there are 4 nuts that hold that on, and then it lifts off of the back plate and exposes the wiring that runs from the terminal blocks over to the switch that activates the rewind. If you determine that that's not working or could be suspect, you can test it by putting a multimeter on it, testing for continuity, which beeps when you have a continuous circuit, and then testing it to see if in fact you've got a good circuit or not. If you determine that the contacts are dirty and you're not getting a good connection, clean it off with a Q-tip and some contact cleaner, and then blow it with some air to make sure it's nice and dry. You can do the cleaning operation while it is still on the clock. You don't have to remove it, but please make sure you got that power turned off. Small silver-colored cylinders that hang down from the motor are there to lubricate it, and they're called oilers. You can remove them either on the clock or when the motor is removed as well. You can unscrew them usually by hand. Once unscrewed, you want to open them up, clean them out with some WD-40. They're usually kind of gunked up from 100-year-old oil that's just kind of coagulated in there. So get them nice and clean like this one, and then fill them about 2/3 of the way with a nice synthetic oil. There's a vent hole in the top of the cap that will allow the synthetic oil to come out over the top if you do overfill it, and then it drips down onto the movement, which is not really a good thing. If you're good with a multimeter and determine that the motor's brushes need to be replaced, there are 2 of them, one on the bottom, one on the top, and they're easily replaced through the thumb screws. The motor's shaft has a worm gear on the end that's covered by 3 screws and a plate that you can remove, and then you can clean the worm drive and the associated gear and pack it with new grease. To reinstall the movement, you go back up to the 2 pins that are used as guides for the movement and connect the pendulum through the verge shaft. But then it's very important not to press it in, not to force it in. You need to loosen the adjusting screw on the cable drum. Again, you don't have any weight on the cables at this point in time. And then you turn the gear drive to the point that it clicks in so that the gears are aligned with the movement in the gear drum. And at that point you can continue on and insert the 4 screws to attach the movement to the back plate. Reattaching the weights is fairly straightforward. One at a time, attach the lock nut at the top. 11 pounds, keep it balanced. and then remove the clamp and do the same thing on the left side, and you are good to go with the weights. With the movement back in place, we're now ready to re-engage the gears of the cable drum to the gears of the movement. Unlock the drum. The weights now connecting their power to the movement. The movement has been energized and is ready to run. You can reach down, give the pendulum a little bit of a kick, and she's off and running. Ready for another 100 years. Master clocks helped synchronize the early industrial age through to the mid-1900s. The international time recording weight-driven master clock set the standard for both a robust movement as well as very highly accurate movement and machine. It's testimony 100 years later is its durability, the fact that they look great, they run well, and they're really something to be proud of. The engineering found in these early IBM clocks was key to provide accurate timekeeping throughout the early industrial age. IBM's clock business fueled its development of the computer age, which was key in transitioning the company into the IT leader it is today. We hope you enjoyed this video, learned something about the master clocks and how to service them, and look us up on the web at internationaltimemachines.com or .net, as well as on YouTube for lots of other tips and techniques, as well as some artistic looks at the clocks. Thank you.